So remember I said chapter 1 has a ton of introductions, but also a ton of vocabulary. So in the last section we just got done discussing different angles. This section also has different angles, but it's pairs of them. So the first kind of vocab is adjacent angles. Adjacent angles means you have two coplanar angles with a common side, common vertex, and no common interior points. So what that means is they have to be right next to each other. That's what adjacent means, side by side. They have to be sharing a side and a vertex. So they have to be sharing that side. So an example of adjacent angles that would not work would be when they are more like that. Notice how they don't share that side or that common vertex. So that's what makes them not adjacent. Okay? Vertical angles are the ones that make the X shape. So you might draw a little X to remind yourself. Vertical angles are on the opposite sides of your X. So 3 and 4 are vertical angles, and 1 and 2 are vertical angles. So you got to be careful. It's not next to each other, it's on opposite sides. So vertical, up and down, or left and right, depending on how you draw your X. Okay? Complementary angles. Those are angles that they will always add up to 90. And so each angle is called the complement of another. So when I have these two angles, they can add up to 90. Those are complementary. They do not have to be side by side. Same thing here. This little box in here represents that these will add up to 90. That's called the right angle symbol. So you will know that those will be complementary. And then the last one is supplementary. Those add up to 180. Every time they add up to 180, they will form a straight line. So you should be knowing if they're supplementary. So 3 and 4 would be supplementary there. Okay. Down here at the bottom, we're going to practice some of that vocab. First, it's asking me, if I can get this in here, angle BFD and angle CFD. So BFD is here and CFD is there. Asking me if those angles are adjacent. Remember, they have to share a common side, which they do, FD. They have to share a common vertex, which they do, there. And they have no common interior points. What that means is you can't have an angle inside of another angle. So they have to be separated. They have to be one next to each other. So this one is false because I can't have those common interior points. All of this space inside they share, that can't happen. They cannot have one angle inside of the other. So that is not adjacent. Okay, next one. Angle FAFB, which is here, and angle EFD, which is here, are those vertical angles. Okay, remember we're looking for an X shape. So here is one line that creates that X. I would need this to be my X. If I follow suit with my angle, that's not going to be an X shape. So it has to be a straight line. So this would also be a no because I don't create that X, which in terms means that these are not opposite rays. Okay, so remember for a vertical angle, they have to form that X shape with straight lines. That's where the opposite rays part comes into play. Last question. Are these two angles, AFE and BFC, complementary? Complementary means that they will add up to 90. Those two do, so that means that those would work. That is incorrect. It should add up to 90. There you go. All right, you're going to pause the video and try the next one. So it's asking, is AFE and CFD, are those vertical angles? That would be yes. When I create those lines along those angles, sorry, just a second. When I create those lines along those angles, I do create those nice straight lines and get an X shape, so that is a yes. All right, is BFC and DFE, are those supplementary? So do these two angles, 118 and 28 degrees, do those add up to 180? The answer is no, so they are not supplementary. Last question here, is BFD and AFB adjacent? common vertex, common side. They don't share the insides, meaning they're side by side. So yes, those would work.
Mrs. Schock, please call the office. Mrs. Schock, please call the office.
Okay, this next part is where you're just making sure you understand how to read a picture. So you're going to get lots of diagrams in geometry, and you cannot assume anything. You cannot. So unless they have drawn it in there, you cannot assume if things are congruent, right angles, congruent, etc. So you're going to decide, can you make this conclusion from the information in the diagram? So here is the first. It says, is TW congruent to WV? How do I know that they are congruent? Because, do you see those little dash marks? That means they are congruent. So in the picture, it has the congruency mark, so yes, that is true. Do I know if a line segment PW is congruent to WQ? It looks like it is, but I do not have any tick marks saying that they are. So my answer is no, because they could be off by like 1 centimeter, and without me actually measuring it, I would not know that. So they did not mark it, so my answer is no.
Kara Briley to the office, please. Ms. Schock, please call the office.
Asking
Kelsey
me,
Chalfant to the office, please.
sorry, asking me if angle TWQ is a right angle. Remember, the symbol for a right angle is the little box shape that they put in the corner. That is not present, so I cannot assume that that is a right angle. So again, my answer is no, because there's no little box shape. And then the last one, does TV bisect PQ? First, I have to know what bisects mean. Bisects means that this would be, W would be a midpoint, and PW would be congruent to WQ. My answer again is no, because we did not know that PW and WQ are congruent. So this is also no. TV is not congruent to PQ. Okay, so again, that was just practicing making sure you can read diagrams, because like I said, in geometry you have a lot of those. So you cannot assume if they are congruent or assume other things unless they have it marked. Okay, another vocab word. This is a biggie. Linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. What does that mean? You have two adjacent angles that make a line. That's what linear pair. So it should always form a straight angle. So this will always add up to 180 degrees. So the first postulate, if two angles form a linear pair, then they are supplementary. That's what we just got done discussing. The reason that is so important, because they'll give you problems where they want you to find certain angles, and if you know they're a linear pair, you know that the small ones are going to add up to 180. So for example, this says angle KPL and angle JPL are linear pair. They give you expressions for each, and so what are their measures? So what you might do is draw a picture. So the best thing in geometry is, if you're unsure what it looks like, go ahead and draw it. So angle KPL, I know would look like that because P is in the vertex. And then it also says JPL. So I know that they are a linear pair. So I'm going to flatten this one out here and put K over there. So the first way that I had it didn't work, because since it's a linear pair, it has to form a straight line. Now, if you wanted to, you could put in those expressions. Since it's a linear pair, these two smalls have to add to 180. So that's what I did. I put KPL in, which is the 2x plus 24, and I put the JPL in here, and then I set it equal to 180. Now you're just solving the equation. So I combined my like terms, subtracted 60 divided by 6. Once again, they did not ask for x, they asked for the angle measurements. So I have to plug 20 back into these expressions. So 20 times 2 plus 24 is 64. 20 times 4 plus 36, 116. Ask yourself this question, what should these two angles add up to? It's a linear pair, so these should be adding up to 180 degrees, which they do. Alright, you're going to pause the video and try the last one. On the last one, again, it's a linear pair. So I would draw my angle. So I have A, D, and B. And then I have B, D, and C. So that could be your diagram if you needed it. A, D, and B is the 3x plus 14. And then the other one is the 5x minus 2. They want you to find those angles. So since it's a linear pair, you would just add them together and set it equal to 180 and solve it. So combine my x's, combine my numbers, subtract 12 over and divide by 8. Again, they did not ask for x, so I would need to plug into those angles. So I plugged into these expressions up here and got 77 and 103. They add to 180, so I know they work. Alright, last question here. Angle bisector. Angle bisector is a ray that divides an angle into two congruent angles. So here's my diagram. Ray AY would be the angle bisector because it bisects this into two congruent spots. I know it's congruent because it has those little arc pieces in the corners. So let's see what this last question says. It says AC bisects angle DAB. If angle DAC is 58, what's the measure of DAB? Well, I went ahead and drew a picture. So here's my angle DAB, and it said AC bisects it. So I went ahead and drew in that ray, and if it bisects, I know that these two small angles have to be the same measurement, which is valuable information, because if it tells me that DAC is 58, then I should also know this one now, because that one would also be 58. So then I go back to my question. It wants the angle DAB. Well, DAB is this big angle, so I would have to pay attention to what they're asking. My answer would not be 58, it would be the 116, because I would have to add the two smalls to equal the one big angle. Okay, that wraps up section 1.5. So again, vocab in there, adjacent angles, vertical angles, complementary, supplementary, linear pair. All of those you will hear over and over again. So you want to make sure you have them down pat from the beginning. Let me know if you have questions.